All right, welcome back to the second day of our virtual lessons here. I'll start off by saying two good pieces of news. One, the video should be a lot shorter today, and two, the homework will be even shorter than that. I think the homework might take you 1 to 2 minutes, so not a bad deal there. We're going to start out by talking about a concept that I didn't get to in yesterday's video, which is called the complement. The complement is, instead of finding the probability that something does happen, it's finding the probability that something does not happen. So let's go ahead and look at some notation. We should recognize this from yesterday, the probability that an event does happen. And I just put A in there to represent any event. Yesterday, for the homework, it was the probability of rolling a certain number on an 8-sided die, or the probability of landing on a wedge on a spinner, something like that. Well, to write the complement, we simply put a little asterisk next to the event. So that means the complement of A, or in other words, what's the probability that A does not happen? Now, let's take an example of Stephen Curry. All right, for those of you who don't know, he's a really famous NBA player, really known for his three-point shooting. And if he shoots a shot, a three-point shot, he's either going to make it or he's not going to make it. There's no in between. One of those two things happen. So knowing that, we should be able to take the probability that he does make the three-pointer plus the probability that he doesn't make the three-pointer, and it should equal 100%. Well, in probability, when we talk about 100%, often we just call it 1, right? Because we're dealing with those numbers that are smaller than 1, like 0.35 or something like that. Well, if you add up 0.35 plus 0.65, you get 1, which is 100%. So, off camera earlier, I Googled his career three-point percentage, and the probability that he makes a shot, makes a three-pointer, was, what's really bouncing, is 0.435. In other words, he's a 43.5% three-point shooter, which is incredibly good. If we wanted to find the probability that he doesn't make it, lost my feed here. Hopefully that'll stay back. We use this little formula here. It states that comment that I made earlier. Hopefully this will quit. The probability that something does happen I think it's going to work. Nope. If you guys stay tuned, you might get to see Mr. Taylor throw a projector against the wall. Let's see. Is it going to work? As soon as I start talking, I bet it quits again. All right, here we go. The probability that something does happen plus the probability something does not happen is 1. There's no other possibility. What else could happen? He's either going to make it or he's not. So if you add it up, there are two probabilities, and it was less than 1, that means there's a probability that something else happens. That's impossible. If it added up to more than 1, well, that's more than 100%. You can't have more than a guarantee. So what we're doing is we're going to take the subtract the probability that something will happen from both sides, and we get the probability that something won't happen, the complement, is equal to 1 minus the probability that it does. So if we wanted to find the probability that Stephen Curry will miss a shot, or the complement of making it, it would be equal to 1 minus the probability that he does make it. So So the probability that he misses, or the complement of making, is 0.565. Alright, I hope a really simple concept. If you want to find the probability that something doesn't happen, which is called its complement, you take 1 minus the probability that it does. So let's look at a couple of examples. It says there's a 0.63 probability that it will rain. What's the probability it won't rain? So we want to find the probability of it not raining, which is the complement of rain, and that should be equal to 1 minus the probability that it will rain. Well, the complement of raining, the probability of it, is going to be then equal to 1 minus the probability that it does, which is 0.63. So the probability it won't rain, forgot my complement there, the probability that it won't rain is 0.37. That's it. That's all there is to the complement. We got one more. Says there's a 5/8 probability that Drevin will get kicked by his sister. What's the probability he won't get kicked? So the probability that he won't get kicked is going to be 1 minus the probability that he does get kicked. So the probability that he won't, or the complement of getting kicked, is going to be 1 minus 5/8. I hear my dogs there. Rigby, hush. That is 3/8. Polly, no. All right. One more concept here. And this deals directly with your homework. All right, this is called the law of large numbers. All right, there's two different kinds of probability. I got a package delivered. My dogs don't like it. Rigby, Polly. Shh. I'm surprised it worked. Hey. No. It's like kids. You gotta yell at them every once in a while. All right, here we go. Law of large numbers. We have two different kinds of probability. One of them is called theoretical. Theoretical is what you did yesterday. All right. In theory, if you take a 6-sided die and roll it, you have a 1 in 6 chance of landing on a 4. Or you have a 1 in 2 chance of landing on an even number. All right? That's in theory what should happen. Experimental probability says, well, forget all that. Actually pick up the die and roll it repeatedly and record your results. And then you can tabulate the probability from the actual results. You would think that these would be exactly the same, but it turns out they're not. Unless you do it over and over and over and over again. That's what law of large numbers says. It essentially says if you try and experiment 5 times, if you try and experiment 100 times even, the experimental probability and the theoretical probability won't match. But if you do that experiment 1,000,000 times, 1,000,000,000 times, 1,000,000,000,000 times, or whatever, then these numbers should be really, really close to these numbers. The more trials you do, remember that word from yesterday, the closer the experimental probability gets to the theoretical probability. This is why casinos make money. And they don't make money because if I sat down at a slot machine and I put my $10 in and I lose, well, they just made $10, no big deal. Because the person sitting next to me may have won just $500. But there's going to be a whole lot of people who lose compared to people who win. Right? They set the odds on those slot machines for where they come out ahead. So the more trials you do in real life, the closer it gets to the theoretical probability. And in theory, they're going to win. There's a reason they just stay open. Right? So here's what we're going to do for your homework. you're going to look at something that's called a four-sided die. They exist. They're in the shape of a triangular pyramid. All right, and if we looked at the sample space for rolling a four-sided die, it should just be the set containing 1, 2, 3, and 4. And in theory, the probability that you roll a 1 should be 1 in 4. The probability that you roll a 2 should be 1 in 4. The probability that you roll a 3 should be 1 out of 4. And the probability that you roll a 4 should be 1 out of 4. Okay? That's what we did yesterday. The probability of those events happening should each be 1 out of 4. So what I'm going to have you do is roll a virtual four-sided die on Google, and I'll show you how to do that here in a second, and fill out a Google form. You're only going to do it 10 times. Your results will not come anywhere close to this 1 out of 4, 1 out of 4, 1 out of 4, 1 out of 4. In fact, you might have 6 times where it lands on 3, or you might have 5 times where it lands on 1. That's okay. Right? Go ahead and enter those numbers, and then the more people who do it, the closer the experimental probability should get to the theoretical probability. All right, so let me erase this, and I'll show you how to do this on Google. As with most things on Google, it's pretty simple. So you will open up a new tab, and then in the search bar, type in four-sided die, and you should get a virtual four-sided die. And you can see that when this one rolled, it landed on a 4. So you'll also have the Google form open, and you'll go through and fill out that you had a 4. Now I did this earlier in the video that you guys didn't get a chance to see, that's why those are filled out already. But you'll put in the 4. All right, and then you'll come back and go to roll again. You get a 2, so go to your form, fill out the 2, etc., etc. Do it 10 times until you hit submit. All right, I'll tally all the results from everybody, and we'll see how close our experimental results get to the theoretical results. So homework, 1 minute, maybe 2 minutes. All right, so you're welcome there. Should be short and sweet. I hope everybody's doing all right with the virtual assignments. If there's any problems you're running into, whether it's in my class or another class, do your best to communicate with that teacher. Reach out to me. And if I can't help you, I can't answer, I'll find out somebody who can. Miss you guys. Hope everything's going all right. We'll see you tomorrow.